Hello student, in this video I'm going to explain you the use case diagram, and in next video I'm going to explain the class diagram. So before starting with this, first we will see what is OOAD. OOAD stands for Object Oriented Analysis and Design. This is a technical approach for analyzing and designing an application, system or business by applying the object-oriented programming as well as a visual modeling throughout the software development activity. So this object-oriented design involves the implementation of conceptual model produced during object-oriented analysis technique. The implementation of this includes the following things. First, the reconstructing the class data as per the necessities. Then the implementation of methods which consist of internal data structures and algorithms. Then implementation of control flows. Implementation of association and different types of relationship. Next we will see what is class and objects in object-oriented programming. First, the class. So to define a class is nothing but a blueprint that is used to create the objects. So this class defines what objects can do. So a class is user-defined blueprint or prototype from which the objects are created. So it represents the set of operation and methods that are common to all objects of one type. So this class is a user-defined data types which holds the different data members and member functions which can be accessed and used by creating the instance of a class that we called as a objects. Next we will see what is object. Object is nothing but an instance of a particular movements in runtime, including objects and data values. Then there are different ways of message passing. So message passing takes place to make the interactions of one objects with another objects in a harmonious manner. So these objects play an important role to communicate with each others. So features of message passing consist of different types. So message passing between two objects, we called it as unidirectional. Message passing enables all interactions between the objects. Message passings are essentially involves invoking class methods. Objects in different processes can involve the message passings. Next we will see what is inheritance. So inheritance is nothing but one of the mechanism in which one class acquires the properties of another class. So with this we can reuse the fields and methods of existing class. It provides the reusability. So the mechanism of inheritance is to inherit the properties and behavior of one class with the other class. So there are different types of this inheritance. So first is single inheritance. So properties of this superclass are derived in this derived class, that is called as single inheritance. Then next is multiple inheritance. Two superclasses and one derived class, that is called as a type of multiple inheritance. One superclass, two derived class, and then one subclass, that is a hybrid inheritance, combination of previous two inheritance. Multi-level inheritance, one class is act as a superclass, one is derived class superclass. That way it is done in multi-level inheritance. Then there is another type of inheritance that is called as hierarchical inheritance. So one is superclass, then the derived class, and then the this class will act as a superclass for these derived classes. The next is generalization and specification. So generalization is one of the process of extracting the shared characteristics from two or more classes and combining them into a superclass. So it is a shared attributes of association or methods that is took place. So in this generalization, two classes, the properties are extracted into this another class. So generalization process, the common characteristics of two classes are combined in a form of higher level of hierarchy took place. So these subclasses, and this is called as a superclass for this. So generalization. Next is a specialization. The reverse process of generalization is specialization. So in this, a distinguished features of this vehicle, air and aeroplane class are used in a form of specialized class from the existing class vehicle, air and then aeroplane. So this is a form of specialization. The next is aggregation and composition type of relationship. Aggregation or composition is one of the relationships among the classes by which class can be made up of any combination of objects with other classes. So it allows the objects to be placed directly within the body of the class. So this aggregation implies the relationship where child can exist without that parent class. So this car is nothing but a parent class, this engine is a child class. So without this parent class car, the engine can be exist for some other purposes in some other vehicles. So that is a type of aggregation. The next is composition. Aggregation has a or part of relationship with ability to navigate from the whole as a part of it. So this is engine is one of the part of car, wheel is one of the part of car. So that way we can link. So these are all the classes and these are the child class and this is called as a parent class. Next is composition, which implies where the child cannot exist independent of that parent. So person is a parent and this is nothing but we called it as a child class of this person class. So head, hand and legs. So this is a compulsory or most type of relationship that is included in this. These will not exist with this parent class person, these classes. And next we will see what is dynamic modeling. So after seeing the static behavior of the system is analyzed, the next particular behavior of the system with respect to time and external changes need to be examined in dynamic modeling. So this dynamic modeling can be defined as the way of describing how an individual object corresponds to an event, either internal events triggered by another objects or external events triggered by outside worlds. In this, the functional modeling also play an important role. In the functional modeling, will show the processes that perform within one object and how that objects will change its as it moves between these methods. So this functional modeling specifies the meaning of operations of objects modeling and actions in dynamic modeling, which is takes place. So this is a functional modeling can visualized in following steps. First, to identify the type of inputs and outputs. Then construct the data flow diagram showing functional independence, which is already seen in data flow diagrams. So state the purpose of each functions, identifying the constraints and specifying the optimization criteria. Then in UML, concepts can be support the entire life cycle. So UML is nothing but unified modeling language, which describe the general purpose visual modeling language to visualize, to specify, to construct and document the software system. So this UML is nothing but interactions of your applications with outside world in a form of use case. So visualizing object interactions, we called it as sequence and collaborations diagram. Structuring a system, we called it as a class diagram. View the system architecture by looking at the defined packages. So components of the system, we called it as component diagram. So these are the few types of the diagrams in UML. So UML is one of the meta model which defines the notations to be used to modeling that particular language. So it is divided into 4 views. Structural view consists of class and object diagram. Implementation view consists of component diagrams. Deployment view is under environmental views. We consider the deployment diagrams. The behaviorally changing system behavior is shown with the help of sequence, collaboration, state chart and activity diagrams. Then the user model view is describe the perspectives in considering users' perspectives are shown. Structural model, a statical view of the systems are shown based on the problems and then its solutions. So behavioral view, that is changing view of the system with time, is shown in interactions, collaborations amongst it is shown. Implementation view is structural and behavioral aspects with the help of realization of that system is shown. Environmental view, again the suitable software and hardware environments are selected in this environmental model view. Then there are basic two types of the UML diagrams, structural diagrams and behavioral diagrams. Structural diagrams shows the fixed view of the system. Behavioral diagram shows the changing view of the systems. That is called as dynamic modeling, and this is called as static modeling. So under this, in this particular video, I am focusing on use case diagram of behavioral modeling. So behavioral diagram consists of use case diagram, activity, sequence, communication, state, machine diagram, timing diagrams, and interactions overview diagram. So in this, I'm going to explain the use case diagram. So the class is set of classes, interfaces, collaborations, and relationship. Object is nothing but instance of a class. Use cases are describing the functionalities provided in the systems with the help of actors, and then the use cases. The interaction, that is communication between the two use cases. State, a different state behavior is shown in a state chart diagram. Activities, the flow of activities are shown. Components, the physical structure is shown. Deployment, how the hardware software systems are communicated with each other. And grouping of classes is nothing but a package. So in the use case diagram, describe how the system interact with the outside actors. So this is a graphical representation of use cases, and the actors are shown by considering the functionality of the systems. So it consists of boundary, actors, use cases, and its relationships. So use case is one way of representing system functionality. So use case refers as a system behavior and the functionalities. We also consider the set of activities which produce some output from considering a input. So these are the notations used in use case diagram. This is a system boundary diagram. These are called as use cases. This is called as actors who are going to play some role in a system. Association is nothing but the interactions between actors and the use cases. Generalization is a type of inheritance. Include, if one particular use case is interact with other use case, and this is a must type of the conditions. Extend means optional use case with interactions of one use case with another use case. Note is one of the comment part is shown using a note. So actors are triggering use cases. We called it as the stakeholders who are going to perform some role in a use case diagram is called as actors. So this is an example of use case diagram for ATM machines. These are called as actors, customer and technician and the bank. These are called as use cases. So customers interact with checking balance, deposit funds, withdraw cash, and transfer funds, which is linked with the banks. And technician is maintaining and repairing. So these are the functions who are responsible by these many actors. It is shown by connections between them. Then extends is type of relationship linking the optional use case and standard use case. Example, registering course. So registering for a special course, so extend type of relationship. This is having a loose coupling between them. So registering university registration system. So registering for the classes. So this is a optional type. So register for the special class. So this is called as extend association of two use cases. These are the actors, students, bureau office, then instructors, and registration clerk. Next is type of relationship, include relationship. It is linked between mandatory use cases. So to authorize a car loan, standard use case, a clerk must run a clerk check a client credit history, and this is under the tight coupling of it. So this customer is having a primary actor. These are the secondary actors. So include, so process home equity loan application, assess a home value. This is include use case. To process home mortgage application, process auto loan applications, or process credit card application, check a credit history are the mandatory one. So this is a include use case, and these are the accessors, credit card bureau and loan officers, actors who linked with these use cases perform that particular thing. So as we seen, extend and include. So extend is nothing but a optional, include is nothing but a compulsory. It is a compulsory one. not an optional one, has at least explicit extension location, no explicit locations here. This is the example of use case diagram of login system and logout system. So this user is one of the actors. These are the use cases. Login and logout, for this user is responsible. So this is connected with the help of association relationship with it. So this use case is connected with the CAPTCHA. So this is a include type of relationship. So this is a compulsory one. Without CAPTCHA, the user cannot log into the system. Similarly, without entering the username and password, user cannot log into the system. So these are mandatory use cases: CAPTCHA, password, entering passwords, and usernames. So that's why it is an include type of relationship. And this is the another enter password. So use case is nothing but answer security questions. So this may be entering password or extend type of relationship. So the use case diagram example for website use case. So considering a user and webmasters, so user can log in, browse and search a document. So for this, downloading is also possible for users, and user can also view the events only if he is logged in. So webmaster is responsible for adding users, uploading documents and posting the events. So uploaded documents have to be put in one particular folder. When a user is added, the company is also added. So these particular use case diagram of websites use case. So site users and webmasters are the two actors, and these are the use cases. So this site user is responsible to do these particular functions. So this is connected with site user: search docs, browse documents, view events, and log in and upload the doc. Webmaster is responsible actor as uploading documents, posting a new events on home page, or adding users. So adding users in this particular use case require downloading documents and preview documents. So this is called as include use case here. Include use case to perform this particular use case, this should be included to run this use case. But to upload documents, this is the optional thing. So that's why extend use case, manage folders. Add users also extend, add company can add or webmaster can. That's why this is a optional thing of use case. The next, the example is library management system use case. So this is the name of use case diagram. These are librarian is one actors, members is another actor. So member may be a student, teaching staffs and non-teaching staff. So this is primary and these are the secondary actors. Librarian is responsible to issue a books, return a books, renew books and maintain records. That's why it is connected to librarian. These issue books include check valid members use case, check book availability and check book limits. So these are compulsory one. So to perform this issue book operations, to run this particular use case, so that's why include is used. Returning book also consists of compulsory fine calculation. So include type of relationship is there. Renew and due date also consist a type of include relationship is here. These members are related with issue books, return books, renew and maintaining records. So these are related with them. These are the references which are referred to prepare these PPTs. Thank you.